Alright, let's look at part B, finding the domain of functions. And remember, the domain is the set of all x coordinates that work in the function. And to answer domain questions, you typically start by kind of answering the opposite. What can x not be? And so it depends on what kind of function you're looking at. If you have a rational function, or any function that has a variable in the denominator, you don't want the bottom to be 0. So we're going to start by factoring, and x squared minus 3x minus 4 factors x plus 1, x minus 4. Nothing's going to cancel on this one. And as far as domain is concerned, whether or not something cancels doesn't matter. We need to make sure that this denominator does not equal 0. We definitely don't want that to equal 0, because if it does, you'd be dividing by 0, which is not allowed. And it turns out that the values of -1 and the values of 4 would make my bottom 0, but again, that's what x cannot be. So my domain, I prefer interval notation. If you want to leave it like that, you can, but interval notation, I'm going negative infinity. We're going to take a brief stop at -1. I can plug in anything between -1 and 4, so I'll go from -1 to 4, and then again, everything after 4. So there's number 22. 23. Again, you're trying to think about what can screw this up. Like in a fraction, a 0 in the denominator screws it up. With a radical, or with a square root, or any even root really, what you don't want to do is have a negative on the inside. It is okay to take the square root of 0. So the inside must be positive. So you can take the square root of 0, so it could be positive or 0. And the way we figure that out is we set the equation 4 minus 8x, and it must be positive, greater than 0, or equal to 0, and we solve that equation. So -8x greater than equal to -4, divide by -8, and don't forget that when you divide by negative, you must change the sign. So you get 1/2. And my domain is everything less than or equal to 1/2, so that means I'm starting from negative infinity, going all the way up to 1/2, but no greater. And I can equal -1/2, so I will bracket -1/2. Yep. Alright. And the last one, 24. Natural logs, or any log, doesn't matter what the base is very similar to a square root, except, unlike a square root, a natural log, you cannot take the natural log or any log of 0. So this must be positive, which means I need to take that inside, and this natural log will only work if the inside, also known as the argument, I can't do a good greater than sign, is greater than 0, and we'll add 8 to both sides, and my domain ends up being all values of x greater than 8, which means I'm starting at 8 and going all the way to infinity. Again, I'm okay with set notation, but I prefer interval notations. And there are things later on in the year where interval notation will be preferred. Yeah, that was the last one for this section.